Today I'm going to talk about Guerrilla RF's mixer products. GRF7001 is a single-ended mixer. It comes in a very small DFN6 package, 1.5 by 1.5 millimeter. It is very flexible in tuning. It can have frequencies down to 10 to 20 megahertz up to around 4 to 5 gigahertz, depending on your tune. It has a conversion gain of around 5 to 6 dB. Very good linearity, 25 dBm or so. LO to RF and IF isolation is around 20 dB, and it's very highly flexible tuning different bands. Our current website shows a default tune of around 800 to 900 megahertz with an IF around 150 megahertz. We have plenty of custom tunes on the website that show anywhere from 20 megahertz up to 4 gigahertz. So a lot of different applications that can be used. And if there's a custom band that is missing, our applications team will be happy to help. So the 7001 is a little different than a traditional mixer. It has an integrated LO buffer, which allows the application to use a lower signal for the local oscillator, the LO. Typically, around 0 dBm is all that's required versus a mixer that doesn't have this active buffer might require 18 to 20 dBm. So it's an advantage to reduce some component placement count in the overall application. And we can show you how to tune that amplifier to get the best performance. The other blocks, I mean, it's essentially a mixer that the IF and RF are tied together, so it is bidirectional. So you could have some tuning on the IF port, and if you need to change your layout, make it an RF port, it's very flexible to be able to do that. They're essentially tied together at one node, so it's good and bad. It can cause some challenges in tuning that output, but the flexibility to be able to assign it to either RF or IF is very useful. We have data sheet has quite a few recommendations on tunes and tables, where the application team has gone through common bands, and we've generated components that can be used to tune each port to get the desired performance. The LO port is essentially, you want to tune the best input return loss for your desired frequency. We have very good starting points, and if that frequency is slightly out of the range we have in the data sheet, you can use the network analyzer. Looking into that port can be helpful to determine that resonant frequency that you want to tune. And again, the applications team at Guerrilla can certainly help you with that. The IF and RF ports are similar in the sense that we have predefined values for certain frequencies. The IF port typically requires a band reject filter. It's essentially a band pass for the IF, but to get the best performance, we use a parallel resonance to notch the RF signal. So you'll have two components that resonate at your desired frequency on the IF, and then we have two components that are in series that will resonate to give a band pass frequency. So again, the Guerrilla RF applications team can help with that tuning criteria and get you to where you need to be for your desired application. Up conversion is when you have a frequency from the LO that is lower than the RF frequency, and you're trying to hit an IF frequency that's higher. So, for example, if you're transmitting around 400 megahertz and you have an LO of 100 megahertz, up conversion would be you're looking at frequency around 500 megahertz, so it's above the RF frequency. And then down conversion would be the opposite. If you had 400 megahertz, LO was 100 megahertz, you would subtract that to look at the 300 megahertz frequency. There's high side injection and low side injection, meaning is the LO frequency higher than the RF, or is the LO frequency lower than the RF? And those can be achieved to either do a down conversion. So our data sheet, for example, has high side injection example. So RF is around 800 megahertz. The LO is 960 megahertz to achieve a lower frequency in the IF band around 150 megahertz. Conversely, if there was an application for low side injection, say your RF was 900 megahertz and your LO was 800 megahertz, that would achieve the converted frequency, still IF of 150, but now your LO is on the lower side of the RF frequency. So. 7001, again, it's a single-ended mixer, and it's very simple in terms of there's not a lot of internal filtering or image rejection or harmonic rejection. It's so in the sense it makes it more flexible to use across a wider range of frequencies, but the downside is you cannot achieve the same level of isolation between the ports as you could with a more advanced mixer that maybe it's a balanced mixer, or maybe it is tuned for a specific frequency combination that has internal filtering. So there's a parameter called LO to IF rejection that is the amount of signal that your LO injects into the mixer that still bleeds through into the IF. And that's something that you typically don't want to have in the system. So the better the rejection, that typically helps performance. Single-ended mixers have a difficult time achieving a good level of LO to IF rejection. You're limited with the filtering, and sometimes the frequency spacing. For example, if you have a really close RF and LO, maybe they're only 20 megahertz apart, it's pretty much impossible to find a filter that narrow that would achieve the level of isolation that you're trying to achieve. We have another product, the GRF7042, that is a balance mixer that uses two signals 180 degrees out of phase that basically help to cancel out the even order products, mixing products that achieve a better level of isolation. So I'd say that's the main weakness of this mixer, is the LO to RF and IF isolation. We have some tricks that can help. Certainly contact our Guerrilla RF applications team, and we'll do our best to reduce, to improve that performance the best we can. Yeah, so one trick to help with the LO to IF isolation is to have an amplifier that has a very good reverse isolation in front of the signal that's going into the mixer. And in S12, basically the reverse gain, or the isolation of the amplifier, helps to improve the isolation that you're trying to achieve in the system. So that's a common practice to have an additional amplifier if you choose to use the single-ended mixer approach. GRF7042 is a double balance mixer. It's a slightly larger module, 2x2. It uses differential inputs to help cancel out even order harmonic products. It requires external balance to basically split the signal from a single-ended to two 180-degree out-of-phase signals. And that can help achieve LO to RF and IF isolation. It kind of allows you to have a broader bandwidth in the actual application, but it's very dependent on your mixer, on your balun that is being used. So our standard tune evaluation board, we have a smaller RF balun, a zinger that it's tuned for the 2.5 gigahertz ISM band, but I believe the balun ranges from 1800 to 3 gigahertz. So the RF could tune anywhere along that frequency band, and the IF is a different balun that ranges from 30 to 1.8 gigahertz. So depending on the customer application, these baluns would need to be selected to cover the desired bands. The LO input is single-ended, and it achieves the balun, or the phase splitting within the part. So there's only a single-ended input required, and the tuning is similar to how we tune on the 7001 single-ended mixer, by looking at best return loss for the desired frequency band. So it's simpler in terms of tuning the RF and IF, but it's highly dependent on the baluns that are selected. And we have a few recommendations of baluns that we have used, but we have certainly not exhausted all possibilities that are available. So please contact the Guerrilla RF applications team if you have any specific baluns you wish to ask about, and we can help you. We still feel like this product offers a benefit to those that are looking for LO to RF isolation and just kind of more broader bandwidth and ease of use case, assuming they have the baluns that they've selected for that bandwidth.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.